Hello, I'm Anthony,
Hi there, my name is Ethan.
and for our capstone project, we decided to work on transforming expert knowledge into interactive 3D walkthroughs with our mentor, Clay Grayunke. Um, so our project is an AI-assisted system for capturing expert walkthroughs inside interactive 3D environments. Users are able to upload recordings along with the 3D model, and then the system will convert the demonstration into structured steps that can be anchored directly to locations within the scene. This creates a walkthrough experience that is much more interactive and much more meaningful than a standard video or transcript. For example, instead of rewatching an entire recording to find a single instruction, users can directly navigate the 3D environment and immediately see where important actions took place. The system is designed to make expert knowledge easier to organize and easier to revisit. It'll also be easier to share with others who may not have prior experience with the environment that is being shown.
The thing about traditional walkthrough documentation is that they're usually stored within videos, notes, screenshots, or transcripts. While those formats could capture the information, they don't have that same spatial awareness of where these important parts are, or keep that expert knowledge from the creator. The- For example, well, a normal technician or an expert technician would know that a certain step is meant to occur at a certain place. The reader or user may not entirely understand that, where where that event happens or what order that event might happen in. This could lead to confusion, a repeated clarification, or wasted time that a person would take searching through those long videos. Our project was really motivated by the need for a better way to capture that expert knowledge so that the instructions remain connected to the physical or the reconstructed environment where they matter the most. We wanted to create a system where users could visually explore a scene while simultaneously following guided instructions tied directly to locations inside the model.
So, the main goal of this project was to build a system that transforms the recorded expert demonstrations into step-by-step, spatially anchored walkthroughs. We wanted to combine AI-based transcription and step extraction with an interactive 3D viewer. That way that users could not only read the instructions, but they'll also have an understanding of exactly where each step belongs with very little to no ambiguity. Another goal was to make the workflow simple and accessible by allowing users to upload their own media and 3D files directly into the application. We also focused on improving usability and interaction within the viewer itself so that navigation felt smooth and intuitive even for users who are not familiar with 3D software. Overall, our objective was to create a tool that connects AI-generated documentation with interactive spatial visualization.
Now, the system consists of a React front end, a fast API backend, and a custom built 3D viewer. The React front end would be there to manage the project interaction. It's to how you are able to upload your files, look through the walkthrough panels, and have the user control what they're viewing at any given time. It is the main thing that uh, the customer or the user would interact with. Now, the Fast API backend would handle all of that information. It handle the step extraction, the anchor storage, the communication between the different parts of the system, and the transcription. That way, it can look through the information, store the important parts, where it may be, what pieces the user might want to see in an organized way, so that the spatial layer would be able to go and view it. It would be the spatial layer or the 3D viewer. It would be responsible or is responsible for rendering the uploaded splat or ply models to allow the users to navigate through the scene in real time. Within that viewer, the users could place anchors, attach notes, and visually connect instructions to specific parts of the environment. With those components together, they helped create a complete workflow that took raw recordings and converts them into the interactive spatial documentation that we're hoping to accomplish.
So I would say one major challenge that we encountered was getting accurate anchor placement inside the 3D models, especially when working with different files such as the .splat and .ply files, since each of those formats contain slightly different geometry and rendering behavior. So early on, at the beginning of the project, anchor placement was inconsistent because the mouse raycasting system did not always align properly with the geometry of the scene. We addressed this by improving the coordinate mapping system and basically registering the closest pair of coordinates detected by the mouse raycast. And at the end, this ended up greatly improving our placement precision. I would say another challenge involved usability within the 3D viewer itself. During the testing period, the original controls felt difficult to manage and unintuitive for new users. Navigation often felt way too sensitive or disorienting, especially when trying to inspect smaller details within the super dense models. So to solve this, we redesigned the controls by adding zoom-based navigation, orbital panning, and having smoother camera movement.
The final prototype made from all this helped successfully support the media upload, the 3D model upload, and the AI assisted transcription, as well as the automated step extraction, spatial anchor placement, and freeform note creation. The system can now work with both Splat and Ply files and includes improved point picking for more accurate anchor placements. It also helps feature smoother and more intuitive navigation controls, along with a custom loading animation that helped improve the overall usability. We worked a lot and made sure that we had a pretty solid product. And a lot of this has to do with our mentor, Clay. He was a great help guiding us and teaching us through the pieces to make all this possible.
Once again, special thanks to Clay for keeping us disciplined, hosting the weekly meetings, and guiding us.